Hey, Moki here. I am going to go over IP addresses. This is not me. This is an AI rendition of me, I guess. Studying IPv. I asked AI to make this, and then you can notice how squiggly the keyboard is over here. It's pretty funny. So I made this Excel sheet with the bits. There are 32 bits in an IPv4 address. And so, abbreviation for subnetting, you have /1 to 32, and then you can see each bit is lit up. Let's see. So I just kind of want to explain how these bits work real quick. For the 32 bits, there's a power for each one. The first bit is 128 all the way down to 1, and this is a byte. And the first octet is the first byte. And you have 4 octets, 4 bytes. If they're zeros, they're off. If they're ones, they're on. And you could think of it as light sound, but maybe I can make a beeping noise. So this would just be darkness, no signal, and it's considered a default wildcard. And then we get down to darkness, beep, and then darkness. This is where class A begins. Darkness, beep, beep. This is where private tens start. This this number, I made this really cool, where I can change it around. I just put an if statement in it. If I change any of these, it changes. Oops, it doesn't respond to anything other than ones though. These are private, I just call them private tens. Private in class A. And that's really huge. Class A ends here, 126. There's a bunch of beeps in here. It goes 0, beep, 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 beep. So there's 6 of them in there. This is loop back. This is very unique. Class B begins here, 128. And I can explain this to you, but I think if you make something like this, I can share this with you if you want. Making this really got it through my head. So changing that to 128 here. This is where class B begins. And then we have the private classes inside class B. I call them just the 172s, so it's beep off. I'll just say 1. 101011. This number comes up later. And then it actually has a 16 here, and a 31 here. It's very unique. And this is already maxed out, 255. And then class C, our favorite, most common. Let's see, I think I had an explanation. The class A is for very large networks. It has 16 million hosts. The next one, class B, is for medium-sized networks. It has 65,000 hosts. And class C is for small networks. Now, I'm just going to call this the office. If you've studied IP addresses at all, you've heard this 192.168. You'll hear it a million times. This is the private in class C. This is what's inside your house, inside your business. You'll have you could have this many. I don't know how many that is. It's a lot you could have. Oh, sorry. I'm sorry. So subnetting, usually for class A, is a /8. So you have a huge number. Class B is 255 twice, a squared. And for class C, it's just /24, so it's just the 255. So you can have 255 devices on your private network here. I just highlighted them. I'm trying to keep the colors the same. Class C ends here, and we also have class D that pops up. Class D is 224. I could create it really quick. All I do is just like this. What's the number again? 224. Let me just copy this. Whoa, it's huge. Cut this out. Ooh. I'm running out of stuff down here. Okay. That is way too great. Okay, class D starts. Class D ends. And this is multi-class. 224. How do we get this? 224. 224. 2, 2. Oh, I guess these are all ones. Okay, so these three are 1, 2, 2, 3, 9. 2, 3, 9. Oh, that was it. That's easy. And then these are 0. A bunch of zeros. Grab these zeros up here. There we go. That's class D. I don't know, just give it a random color to it. Color do we want? Light blue, purple. The key thing to remember is this one here is a bit. It goes up to the third one. I don't know, you're supposed to get a feel for it after a while. So subnetting, we're going to use this, and here, let me get to this real quick. So here, I had a question earlier on the test, just a practice test. So I highly recommend talking to AI, Gemini, Copilot. There are really cool places like Netacad to study on, and loginpacific.com. Let me see, I got this guy off. What is that? Reddit. Just look up. This will pop up. This guy made a bunch of practice tests. And this one, man, it's blinding as it's so white. They're really good questions. This is just, you have to memorize this stuff. What document describes the concept of private IP addressing? RFC, what? So 1918. I don't know how you're gonna have to memorize that. And then kind of just click random buttons, but NAT is network. Oh man, NAT, network address translation. There we go. Ooh, got a good picture of it. It's your router in your house. So that hides the internal IP address from the outside world. You're just using it inside your house or a small office. So you can have multiple hosts in the same private local area network. network address translation. Okay, and then PAT. This is the port. IPv4 has 32 bits. You gotta remember it's 32 bits. Which is 192. So remember 192, 168. So that's 1, 1, and then all zeros. Let's go back to 192. 190. That didn't look great. This is 191. C started 192? Get rid of these guys. C starts at 192. I made a mistake here. Try that out. Okay, fix that. So the two ones here are 192. That's for class C. All of these should be 192 in the beginning. And let's go back. That's exactly what that is. IPv4 addresses are expressed with hexadecimal. It is not expressed with binary. I was stupid to actually say that. I started to actually focus. Still made a mistake here. So this one, 101011 is 172. How are you going to memorize that? I highly recommend making some form of a sheet. Oh, this was what I was doing. I did it on Google Docs too. But like I said, these numbers pop up quite often, especially if it's 172 or 128. That's really the easiest one of all. And then, so yeah, 172 is a little harder, but you gotta memorize this number. IPv6 consists of, and I wrote 32, I wasn't paying attention, this is 6. That's 128 bits. So now I'm focusing on 120, sorry, IPv6, which I'm gonna make later. I don't have anything on here. I'm gonna do that. Oh, lost my place. Hexadecimal, and it's not binary, it's not decimal, it's hexadecimal. It's so when we look at IP address IPv4, we're seeing this decimal, and behind the scenes is the binary. But with IPv6, it's not 8 bits. It's actually 16 bits in one. Man. Anyways, it's up to 0 to 15, and then you got 1 to 9 or 0 to 9 is actually numbers. I can just write it out really quick. It's like 0, 1, 2, 3. Oh my gosh. Go the other way. Go vertical. 5. I skip 1. And then I got 15. Did not want to do this. So I get here, where I use A, B, C, D, E, and F. That's it. I thought I made this before. I'm going to do it later, though. I'll work on that later. Double colon is part of the address containing only zeros between that. Yes. A PIPA. That's the automatic private IP address. Allows a window host to self-configured IPv4 address and subnet mask when DHCP is unavailable. A PIPA uses an address block range between these two numbers. A PIPA assigned addresses are valid only for communication within a network segment that a given host is connected to. All right, let's continue on. Which of the following answers refer to valid IPv6? So and you have a MAC address of this, you need to get this back from it. I'm going to go on IPv6 in another video. A type of network traffic intended for a particular group of hosts is called multicast. A type of network traffic intended for a single host identified by a unique IP address is referred to as unicast. Alright, and then anycast is an IPv6 only one to nearest data transmission type. Broadcast is a network host with unknown. So if you don't know, the computer needs to broadcast. Sorry, this thing is a very white screen. So blinding. An IPv6 local address is an equivalent of IPv4's PIPA. That's for IPv6. Which of the following listed below refers to IPv6 local link address? I said it already. Sorry, link local. Link local. It always starts with FE80. So I just talked to AI about this, and I learned it always starts with FE80 for link local. Which of the following answers refer to an IPv4 loopback address? 127. That you have to know. Where is it? Class A ends at the 126, and this 127 is specifically loopback. And then we get to the next one, it's Class B, 128. This is loopback, 127. All right. We have two answers here. IPv6 loopback. So it's a little different for IPv6. Ends in a 1, and since they're all zeros, it's just a semicolon. And in a network, I don't even know why no one would use this. Maybe just to be clarified. In a network using subnets, the term default gateway refers to a network device that enables exchange of data between hosts. That's your router in your house. Which of the following allows to determine which network segment an IP address belongs to? Subnet mask. So if we go back to the subnet, /24, that's what's in your house. There are 255 options, available addresses in the network segment. What is the name of a solution, BLSM, that increases the efficiency of IP address space management by allowing network administrators to divide networks into subnets of different sizes? This is virtual. Oh, variable, sorry. Variable length subnet mask. So you can change the subnet mask in different lengths. Different sizes. Yeah, that's it. Different sizes. That's why it's variable. Which of the following answers refer to the characteristics features of the 10 to so that's Class A, but it's private. I don't even know what to call it Class A, but yeah, there's a Class A private, Class B private. That's why I tried to break off here. So Class A private. That's the 10s. Class B private. I guess I could call it private B. B private. I just call it 172. So you got the 10s, 172, and then this is like your home office, 192.168. Doing that. 172, Class B, private. 192.168, Class C, private. Which of the following answer refers to an IPv4 address range used for loopback? 127. Which of the following answers refer to an IPv4 address range reserved for future use. So that's this one 240. That's E. This is very unique. 240s here, class E. It's reserved for experimental, future use, research. This one's really weird. To the end. Guess I could add that. Got D on here. Let's add that chunk real quick. This is the end. So, got that. I'm sure it's going to be this one here. 240 on all zeros. Is that right? Yep, 240 and then 255. Do I need to copy that at all? No, I do not. So this is 240. And this last one is 255. And this one is going to be where E. Oh, I had to capitalize. E. We got 240 and then 255. So this is just everything is done. And we're done. The entire IP addresses are done. Good color. Red. Like that. Okay. And quiz. IPv4 addressing the leading octet of an IP address. Class A, 1 to 126. So remember, octet is here, the first octet. And we have 1 to 126. I just put a sum of these. See that sum of those equals that. If this one is a 1, it comes out. All right, and then what is a valid subnet mask? That's a funny thing. I missed this. I was like, oh, this is 255, 255, 255. But actually, they put in here 225. That's flip that around. My brain did not catch that one. Maybe it's a trick. Another more valid. Which of the following answers list the default? Because the subnet mask. Hold on. I'll just go into subnet masks. It's got to have one of these numbers because we're going from left to right. So you go 128, 192, 224, 240, 248, 252. I had some way to memorize this. Alright, whatever. Going back. So none of those would work. Which of the following answers lists the default for A? No, the A is the first octet is fixed. Completely kind of here on subnetting. A is here at 8. B is here at 16/16. And C is here at /24. So you're at 24 bits. And we're going from left to right. 8, 16, 24, 32. What is the leading octet value? So leading octet, the first octet for B. So I mean, you could go. You just had A up here, right? 1 to 126. And you're skipping 127 because it's a loop back, but they didn't even try to trick you there. Which of the following answers lists the default for B? So that's the first two octets are full, 255. 192. I'm thinking of home always. 192, 168. C. Class C network. The first three are full, and you only have the last octet available. So you can only have 255 devices at home. until we get rid of IPv4. Move everything to IPv6. Might be in our lifetime. Which of the following answers refer to the IPv4 multicast address? So multicast is D, class D. Multicast is D. So they tried to trick you here. You don't know what multicast is. Others, I guess, trying to trick you with it. It's a very unique one. They have very large networks, medium-sized networks, and small networks. FBC. Which of the answers refer to a solution that replaces classful? So previously we were using ABC classes, now CIDR. What's the CIDR notation of this subnet mask? So you have the 224. This 224 is /27. So if we go /27, this is 224. Now I have this sheet in front of me with this Excel form that I made. But how would we know to go from 127, this dot, to 224? There's many different ways to memorize this, but I'm just going to explain that's what that is. What is the first valid host address that can be assigned to a node residing in the blah blah network? So I could take this. Do I have that in here? What is the network address? They say it weird like that. The first valid host address. That's /20. I don't think I wrote this one out. Let's see if I can just. Let's try to do this one time. Alright. I'm just going to delete the line here. Okay, so we got 10, 19, 136, 143. So we need to get 10 first. So we got 10, then 119. Ooh, that's too high. 119. 19. I think the rest are going to be ones. 119, 136. Too high. 130. 136. 143. Oh, we're so close. Okay, 143. So over here you'll see 10, 19, 136, 143. That's a /20 network. So my cursor has gone right over that 120. That means right here is the last one. The rest are going to be zeros. Just going to copy that. So /20 is a 240. So if I go subnetting, /20 is 240. I don't know what I should call this. Bitwise. So the thing here, what we're doing, this stays the same. So if I copy that, it goes down. Everything out here is going to be 0. Everything over here is going to be 0. This is going to be 0. These two are 1. 1, 1 is 1. Everything else is 0. So the the very first find valid host address can be assigned. Mainly, this will be a 1. Does that make sense? The very first valid host address. That's your answer. 10, 19, 128, 1. Let's see. 10, 19, 128, 1. This is extremely difficult without what I just did. For me. On a test, I don't even know how I'm going to answer that. Unless I can physically write it out by hand. Some people say, oh, doing the math is crazy, but alright, this is /20. Oh, come on. /20. Yeah, I have no idea how I'm going to do that on a test. I don't know what the test allows me to do or have. Definitely can't use this sheet that I created. Have to find out. Let's see. What is the network address for 154? So that's the network address. So that doesn't mean the first one. I just did this one right here. It means the whole network address. Oh, sorry. I should call that first. I think it's capital. First address. This means the whole network address. So I have the address here, 124, 24, 67. It's not really 0, it's 147, but it doesn't matter. It's going to be zeroed out. On a 22 host, here's the 22 right here. So these ones and zeros zero each other out. Zeros and whatever's over here, zeroed out. 0, 0, 0. These two ones line up. That's why this one is 1, because of these two. So that's the number. 154, 24, 64, 0. 154, 24, 64, 0. 154, 24, 64. I'm going to have to figure out how to answer that without my cheat sheet. Which of the following answers lists the broadcast address? So I also did this work too. 192.168. Let's see. 192.168. What's the broadcast address? So I got the answer here. You see how I show you how I did this. So here's the base address on this network. And you have a /22, sorry, /20. Go here, here's the 20 bit. Probably just ignore this number. Let's just delete that so you don't get confused. Yeah. This is not important. All these are zeros. Zeroed out. 1 and 1 is 1. 1 and 1 is 1. Only these two match up. This is a 0, so these are also 0. Why? It just is what it is. That's the network address. Put that down here if that helps. This is the network address. Now it gets kind of crazy. From this part to here is inverted. It's also called a wildcard to get the broadcast address. So we're now we're going right and left. Anything that has a 1 and a 0 is a 1 here. And 0, 0 is a 0, and then these stay the same. Does that make sense? I hope so. That's how I got the broadcast. 192, 168, 63, 255. If you get one number off, it's going to be wrong. That has a 1 here, so you have to bring that down. Maybe I should highlight that. That's the key right here. There it is. All right, now it talks more about IPv6. 64 is a limited transition mechanism. You know, IPv4 to IPv6. It encapsulates IPv6 packets inside IPv4. So it's 64. IPv4 to IPv6 transition mechanism. Teredo. Miredo, I thought was the same thing. You're sitting here, transition mechanism. But it's a Teredo tunneling software. This is true. The term dual stack IP, you're implementing both protocols, IPv4 and 6. All right, so this is compressing IPv6. I missed these 2 zeros. Everything else was correct. These zeros in a row get compressed to double semicolons. These zeros, they're called leading zeros. You need to remove them. This 0 here, the 0, 2, it's missing. These zeros, you don't remove them all. You just compress it down to 1 0. The leading zeros get removed. And these zeros do not get removed, as they did at the top one. Don't do that. They're not leading. NDP. What does that mean again? No. IPv6. Neighbor discovery protocol. Advertise their presence on a network. Neighbor discovery protocol. And Slack. Stateless. Which is the following allows a network node to auto configure IPv6 address in the absence of DHCP-v6. Stateless. Stateless address auto configuration. I had a conversation with AI about that earlier. That was really cool. An IP address that doesn't correspond to any actual physical network interface is called a virtual IP address. Or VIPA. So I passed this, but that's it for this study. This is really good. And yeah, good luck. Hopefully we can all become this guy and have squiggly laptops. But yeah, good luck. This is IPv4. If you have any more questions, I'm going to work on IPv6 next. Actually, we don't need to. It's more like rote memory for a lot of this stuff. And this is really simple. It's just compress the zeros. That's why I didn't really put IPv6 in here. The hardest part are these questions. Insanely hard. And some people say don't study it, study everything else, because it's a waste of time to get this answer. There may be a guessing way to do it. 192.168/20. How to get this? There's got to be a quick way to do it. That's huge math. I mean, I could just copy and paste and get it done, but let's see here. There's all these bits. You got the math behind it, and then the sum. I don't know. I'll have to think about it. Try to find a quick way to do it. If someone gives me this question, how do I get this answer really quick? Anyways, that's it. Everybody has a good night. A good day.